This video is sponsored by PCBWay. PCBWay specializes in manufacturing of very high quality, low volume, colored PCBs at a very budgetary price. In addition to standard PCBs, you can order advanced PCBs, aluminum PCBs, rigid flex PCBs. They also provide PCB assembly and other related services which can meet your need at the greatest extent. Currently, they are running a Christmas sale festival where you can get free coupons or may have a chance to win a gift in the lucky draw. Let me try my luck and see what I get. Yes! Now I can redeem these beans for amazing products and services from PCBWay. These exciting Christmas projects will help in lighting up your Christmas. To create the cardboard helmet we need cardboard sheets, A4 paper, permanent marker or pen, scissor and a knife, hot glue gun or wood glue, plaster of Paris, sandpaper, watercolor and coloring brushes. From Instructables, I printed out the 2 PDF templates on A4 paper. The link to the PDF files are in the description below. Next, I extracted the shapes from the A4 sheet using a paper cutting scissor. Then I traced the paper cutouts on pieces of cardboard, and using both scissor and knife, I extracted all the pieces of cardboard that I need for this helmet. After that, using a hot glue gun, I joined all the cardboard cutouts. Be careful while using a hot glue gun. Use gloves as much as possible to avoid the hot glue from burning your hand and fingers. By using wood glue instead of hot glue, you can get a cleaner and stronger finish, but hot glue is faster. Hot glue can also be more forgiving as you can reheat and reglue if you are unsatisfied with your seam. Please make sure you follow the exact sequence that I'm showing in the video to avoid unnecessary reheating and regluing of the cutouts. Try applying the glue from the inner side as much as possible to leave the outer side neat and clean. Then create a dense paste of plaster of Paris, apply some in each cracks and all around the helmet. Apply multiple coats of POP to get a nice and smooth texture. Let it dry in the bright sunlight. Take down all the rough edges using sandpaper. If you hit the cardboard, stop. You know you went a little too far. Frankly speaking, you don't need to make it super smooth as Boba Fett's helmet in reality is full of cracks and dents. Cut the visor out after sanding and applying lots of coats of POP. When you're happy with the finish, pick up your paintbrush and paint the helmet. I used watercolor to paint the body of the helmet and pencil color to draw the cracks and the fishes on it. Make sure when applying watercolor, don't use too much of water as that will make the POP wet and the POP will start mixing up with the color. If you don't want to put the LED chaser in the helmet, then you can stop the video right now. However, adding the LED chaser gives the helmet a sci-fi look. For the electronics bit we need 2 4017 ICs, one 555 timer IC, one 10K potentiometer, one 1 kilo ohm resistor, 100 ohm resistor, 100 microfarad capacitor, 20 Zener diodes and 10 red LEDs. The circuit is very simple. The 555 timer IC operates as a clock oscillator or clock generator. The output on pin number 3 goes high, causing a shift. The signal from the 555 IC clocks the 4017 decade counter. Output of 555 timer IC on pin number 3 is given as an input to the 4017 IC through pin number 14. Whenever a pulse is received at the clock input of IC 4017, the counter increments the count and activates the corresponding output pin. This IC can count up to 10, so we have attached 10 LEDs to the circuit. By increasing or decreasing the value of resistance of the 10K port, we can adjust the speed of the chaser circuit. Since only one LED will be turned on at a given time, I have attached just one 220 ohm current limiting resistor to the cluster of LEDs. Now to give the forward and reverse effect, we are attaching another 4017 IC to the circuit. If let's say the first IC connect from 1 to 10, then the second one should connect from 10 to 1. However, now we cannot connect the counter ICs directly to the LEDs as we did before. We have to use a diode to stop the reverse flow of current to the second IC. We have also lowered the value of the current limiting resistor to 100 ohms, as at a given time two LEDs will be on, one running from the left and another one from the right hand side. So this is how my board looks like in 2D and 3D. There are 3 breakout boards in this 100cm by 100cm assembly. Once I had my design ready, I just had to upload the Gerber file to the PCBWay's website and then select the type, color and any other customization that I want, and then just send it for fabrication. For my project, I chose the black color. PCBWay ships from China to most of the countries of the world within 3 to 7 business days. Talking about the quality, it's absolutely mind-blowing. Let's start by soldering the diodes to the board. Then let's solder the 2 resistors to the board. After that, let's solder the 100 microfarad capacitor to the board. Frankly speaking, using SMDs would have given the board a smaller and neater look. Next, I'm soldering the 3 IC bases to the board, followed by plugging the ICs into them. Now, let's solder the potentiometer and the male pin headers to the board. And to conclude, let's solder the 10 LEDs to the board. Solder the LEDs in a way that they look like an arc so they can fit inside the curved edge of the helmet. Now let's quickly test the chaser circuit before putting it inside the helmet. Okay, so I might actually lower the speed a bit. That looks perfect. Thanks again for watching this video. I hope it helps you. If you want to support me, you can subscribe to my channel and watch my other videos. Thanks. See you again in my next video. Bye now.